Awesome. Well, thank you all for coming today. My name is, I'm going to drop that cord so I don't keep making noise. My name's Kenny Parsons. Welcome to Blackbox Containers, Container Security for the Enterprise. So we'll try to keep this high level from a container fundamentals perspective and then get into how that affects the enterprise. So run through this real quick. First, a little bit about me. Quick aside, I'm not the who am I guy that has all the who am I slides, so I went a little different, break the mold. I did a tree of my home directory. I am a senior regional engineer for Set Solutions, now a Trace3 company. I am actually based out of Dallas, so a nice flight up here. I am into DevSecOps, obviously. I enjoy the architecting and designing of proper microservice solutions. And I am also the chapter leader for DevSecCon. That's a global developer community, DevSecOps. We just launched a chapter in Dallas and actually have our first meeting here this coming week. And I'm a bit of a container nut, so I will get on the soapbox about that. I have my own ideas about philosophy and, again, how microservice architecture should be and how you should set things up. But anything containers, I'm in. So, in fact, on our company's Slack, I have Kubernetes, K8s, container, and all that flagged. So I get messages if anybody's saying all those in any channels. So I'm a nut. I will admit that. So like I said, we'll try to keep a high level with the container basics, but just kind of cover our bases here. We'll talk what are containers, what are they not, and the types of containers and or runtimes that y'all might have heard of. So first, what are containers? Well, simply put, it solves the problem of it works on my machine. It worked on my machine, not yours. But straight from Docker's website, and again, Docker's just one of the container engines you can work with, but they have a really solid underlying philosophy. It's a standard unit of software, packages up all your code, all the dependencies, and it all runs reliably inside a container. Everything you need to run your application is inside that container or multiple containers that work together. And the thing about containers is that they're independently scalable. Okay, so some applications break that mold. Again, it's part of the Docker philosophy or microservice architecture. But in general, they independently scale or work together to scale a monolithic or a traditional monolithic application into microservices, which we'll get into that here in a second. What are they not? It's not a VM, please. Please stop saying it's a VM. We will use the term it's like a VM. You can exec into it. You can run commands. You can do just about anything you can do on the surface level with a VM, but it's not a VM. So containers, or VMs abstract hardware, right? So you got your ESXi, your Proxmox, and all your virtualization. They virtualize the hardware. Containers virtualize or abstract the software through the use of an engine. So they share a kernel on the underlying host. Containers don't have their own. So there's a big difference. It's not a VM, so just keep in mind of that. But really that is important when you're talking about proper architectures. How do you build applications inside containers? You know, if you're used to initd or systemd or things like that, it just won't work. So the way you use your applications, the way you build them is just fundamentally a little bit different. So some advantages. These are just my top 3 that I like to talk about with people when I'm just introducing the topic and I'm not wanting to scare them off. Number 1 would be resource efficiency. Again, they don't have their own kernel. They're sharing the host kernel, so you're actually saving on resources. So if you have a host like a type 1 hypervisor and you've got several VMs, one for each application, you've got some overhead there. Even though all those applications, or excuse me, all those VMs may be the exact same operating system. So there's extra overhead. So you do gain some resource efficiency by using containers and sharing a kernel. Obviously, there's some security concerns with that. We'll get into that. Number 2 on my list would be portability. So all the dependencies for the application are bundled in the container, like we said. This means they can be easily moved between different deployments. You can have a test stage or a server environment, trial, production, so on and so forth, developer. And you're able to move that image between all those environments, and you don't have to change anything. All you have to do is just make sure that it has a Docker engine or any kind of container runtime on the host, and you're good to go. On that note, continuous deployment and testing, so containers are really helpful here, again, because it solves that problem of I don't have to reset up the environment and make it the exact same between, like I said, like a dev environment and production environment. So everything you have is right there. You just move the image over or pull the image down your container, and you're good to go. There's obviously a lot more benefits, but these are my top 3 for using them. So some popular container runtimes. These are probably the 3 most popular. LXC is a little bit different than the other 2. It has a little bit different of a philosophy than Docker. I will take it, because I think we'll have time. I'll point it out. LXC is most closely like a VM. You can run systemd, you can run initd and all these things. But it's still a container. It has the entire operating system basically in a file. So it's a little bit different than Docker, whereas Docker and Podman being an alternative to Docker, it's not like that. You don't have systemd without some really major modifications. It's just a different philosophy of how you run things. Docker is kind of your one service micro container that runs just one service. Same thing with Podman being the alternative. So a little bit different philosophy, but it's still it's a type of container. It's a different type of runtime. I wanted to, now that we've kind of got a surface level understanding of containers, and I'll take a quick poll. Who here uses containers on a semi-regular basis? Actually, oh, wow, awesome. I'm with kindred people. I love it. Normally, I'm the only person at work. Everybody else hates me talking about containers. Yeah. Every time we work with a vendor and there's a container or Kubernetes aspect, they all start messaging me saying, hold your horses. So anyway, some common uses. A lot of them you may use. If you don't use these, maybe these give you some good ideas. We'll look at runtimes versus orchestrators. Just make sure we're level set there, and then we'll take a look at how we develop them. So some common uses, OS virtualization. Again, it's not a VM, but you can use it to virtualize an OS to figure out how an application will behave in a particular type of environment. You know, different OSs behave differently. They have different versions of packages by default within the package manager. Maybe it's a BusyBox versus GNU, things like that. So you could kind of understand in a test environment how an application is going to run. I actually just went through this exercise this last week, upgrading a container to a different base image, or upgrading the application, and we just used the different base image and found out, hey, there's some things that won't work because it's just a different version. So really good for that. And then obviously, microservices and distributed applications. Docker is the most popular for microservices. Oh, by the way, LXC is my choice for OS virtualization. It's really easy to spin up, it's very fast, and you get like a persistent shell. You don't have to like do some finagling to get a shell in there. But for microservices and distributed architectures, that's Docker. Again, Podman being a more security conscious version of that. So a microservice, again, level set on the terminology, it's a monolith that's broken down into smaller, independently scalable services. Each container runs a portion of the monolith, hence microservice. This allows you to distribute the core components of an application across multiple environments, maybe even multiple hosts, and they can still act as a single cohesive application, okay? Microservicing allows developers to independently focus on each particular part of the application. So in development, when you're trying to update a monolith, you usually have to update and redeploy the entire thing. Whereas a microservice, you can focus on just the one part that you're working with, and because it's independent of all the other parts and independently scalable, you don't have to touch everything else. All you have to make sure is that it connects. There are a lot of products out there that do service discovery that as soon as you bring it up online, it just comes right back into the application. That's a little bit more complicated, but you get the idea. They're all independent, so you can just work on and redeploy just the particular part you are concerned about. That allows us to do things faster, release faster, and it's just a better model. I can't say better, maybe a little bit more flexible if your environment can handle it. There we go. And I've mentioned Kubernetes a couple times, orchestrators. Just wanted to take a quick pause here. It's not an alternative to Docker. Okay, you know, when I was first learning about this has been like 5-6 years ago. I saw this, Kubernetes being thrown around a lot, and I almost thought of it as like an alternative to Docker, a different way to deploy containers, and it's just not true. Kubernetes uses Docker under the hood. In fact, for its own components, sometimes you can run the components as containers. But Kubernetes is not an alternative to Docker. It runs Docker containers if you so choose. But Kubernetes is essentially just an API server. Okay? It's a big, fancy API server. It's very complex from the outside, but not an alternative to Docker. It's what we call an orchestrator. The API engine and the API server orchestrates all the various deployments and creations of containers, or what Kubernetes calls pods, which have multiple containers inside of them. So not an alternative. And so from here on, when I mention containers, or Docker, I'm specifically talking about an individual container. If I want to talk about a pod, I'll specifically mention a pod, but those are obviously not one and the same. Where are they best used? Again, these are my top 3 that work for me, just some ideas that may work for you. This is not an exhaustive list, but obviously services that can be easily segmented. If you're running a web server, and you are running a database or a Python application on your web server, something like that, those are usually independent of each other. They can work independently. You know, if you're running a web server, everything runs over maybe a TCP stack. And so it's very easily to segment that service. Ephemeral short life workloads. So who here uses like Lambda or Azure functions? Okay, so Lambda, Azure functions, along that line, serverless to be, I guess, exact, along that lines, but I need to run a workload, I need to run an application or a script. One time, actually, I'll give you a good example of this. Working with a company, and they used a very, very outdated version of Ansible, and that was not the version they had on my machine. I did not want to have 2 different versions of Ansible, one being very, very old. So instead, I just put it in a container. I installed the correct version, the old version, in the container, and it was completely independent of my host. And I can just run all the workloads from in there, okay? A lot of jobs that I run, a lot of scripts that have different dependencies, I'll just run them in a container. It's completely isolated. Again, it's kind of like a VM. That's why people think, oh, it's a VM, but it's not. But you can use it like that. You can use it for that function-like workload. Ad hoc tooling, another great way to do it. You know, I just want to run this script, or I want to run this particular version of an application, put it in a container, you're good to go. Let's see here. Great example of this, I was working on a project for certificate management for a company, and I could put all of its dependencies in that application. We could deploy it inside of a Docker container, and then we could just deploy that anywhere, in our Jenkins server, and any of our other CI/CD pipelines, Azure DevOps, whatever, and it would work the exact same because all it needs is the Docker engine. So I just threw some of the tools that I was using to create or manage these certificates inside a container. So that's where you can also use it, but your primary is going to be, you know, microservice segmentation. That's probably the most important and world-changing, to be honest, part of microservice architecture, part of Docker is its ability to do microservice architectures. So how do we make a container? How do we get into the development? First, before you take a picture and crucify me, this is not a well-optimized container. Totally understand that. This was just a quick proof of concept that I was trying to do. I was working with the Azure CLI, and I needed a particular version of something, and I didn't want to have to mess with that on my host, so I threw it in here. But it gives you a good idea of what we could do. So first, sorry, my hands are a little shaky here. I guess just the distance. But that's our base image. So I'm saying I want to use Debian, their base image that they provide to me, which is in and of itself just a bunch of layers of files. So just like this, it's a bunch of layers of files that I don't have access to. I'm just importing them, basically. Very much like an import in Python, okay? I'm saying I want to use their layers, and I start building on top of that. These layers are now also read-only after the layer is finished. So in this layer, I run some updates, I install some applications, I do a bunch of stuff. Okay, cool, I'm done. And I move on, and I copy in my actual script that I want to run, that I'm just trying to get a proof of concept done here. Once I do that, the layer before it becomes read-only, becomes hashed. It's unique. So anytime you change anything in this layer, a version updates, a file updates, whatever, that is now a new hash. This layer will get rebuilt, okay? So anytime you move on to another layer, this becomes read-only, and now you're just building on top of that, okay? It's a like a cached file system. An overlay file system is technically the term. And then I go through and I change the user app, and then I run my script. Cool. Okay, pretty simple. But this is, to start from the beginning, without this from statement, it's just an empty canvas. You got nothing. So you can either choose to import and do all this stuff, or you can import exactly what you want. It's called a scratch image. You can basically build your own Linux distribution inside of a container, okay? Or you can choose another Linux distribution to build off of. There's some really cool things that this allows us to do. I mentioned hashing. That's a security thing that you can use. You can look at hashes to make sure nothing has been changed, so it's immutable. You can analyze those hashes, and if anything changes or it's not what you expect, you can assume there's been a problem or a breach or whatever. It also allows us to, exactly what we did with this from, this is basically just a list of hashes from Debian. I can, instead of rebuilding everything that they do, I just copy it in, and I copy that hash in. Or if I took this, let's say I dropped out this entry point, I could now use all of this stuff as a base image for another image that I want to create. You can basically chain that, and you do that with image hashing, and this layering idea. But there's some security implications there, and we'll talk about that. So security considerations. I want to talk through 4 main areas. Again, this is not necessarily an exhaustive list, but 4 main areas that you typically want to look at the lifetime of a container. Are images, where you store your images, the actual hosts themselves or the orchestrators that are running these images, and then the underlying runtime, so like the actual daemon or the Docker daemon. In our images, so some security considerations here. Number 1, I think this is the most important, the upstream vulnerabilities. And so as you remember in that previous image when I showed you my ad hoc tool that I built, I was trusting Debian's base image. I trusted that they had an updated version, that if there's a package in there that there's CVE and it's really high, or CVSS that's really high. By the way, if you missed the talk over there, that was really good, where she talked about CVEs and CVSS. But let's say I'm trusting Debian to not have a ton of vulnerabilities in their image, or I'm trusting them to consistently update and making sure that they're handling that. I need to establish what I call, this is me, registered trademark, whatever, base image chain of trust. So I have to go back and follow the trail. Because if I import, let's go back. If I import, instead of from Debian, let's say I import from someone else that they built an image with some custom packages in it. And there's a bunch of them out there. I have to go back and figure out, what did he import? What did he build off of? Did he build off of an insecure or maybe an old version of Debian or whatever I'm building on? So I have to go back and establish that chain of trust, figure out what do I have in my environment, inventory my actual images, and follow the breadcrumbs back. Misconfiguration. This is probably, man, it's super important, but this is probably the majority of problems you'll find or security issues that you'll find in a containerized environment. The big one being is incorrect permissions. Principles of least privilege. Obviously, we all know that term, but we don't use it. And it's easy to miss. When I'm building this image, I'll go back here actually. When I'm building this image, this line right here is a huge deal. When I switch to user app, that's a non-root user, it's a standard user, no permissions other than itself. If I miss that, which it's really easy to miss because a lot of times, permissions didn't work, I'll just remove user app and I'll run as root just to get rid of the problem, okay? And this is a proof of concept, so it works, and then how many times do we take a proof of concept right into dev and production? And so it's really easy to miss that, making sure we have correct permissions within the container itself. We're not running things as root. We're not mounting or providing file systems to that container that it doesn't need to have access to. We're only giving it exactly what it needs. So user switching mentioned that. Don't run things as sudo, whatever you want to call it. Do not run that unless you absolutely have to. Usually there's a way, and Podman's a good alternative where they have their rootless mode. It's a really good alternative. A little bit more security conscious and a little bit extras that they provide. But don't run things as a super user unless absolutely necessary. Most of the times it's not. It's usually you just need to be a little bit more thorough when setting permissions within your container or with the files that container is accessing. So it just takes a little bit more work. But you're going to save yourself a lot of grief. Then the Docker socket. So this is a file system socket, and this is how containers interact with the kernel, essentially, how the Docker daemon interacts with the kernel. Some containers request that you mount this socket within a container so that that one container that you mounted it to can then control other containers. So for example, if I have an application, there's a popular one that y'all may have called Watchdog, I think it's called. It basically watches all your containers, and if there's an update or a new image available, it'll automatically pull that and then rebuild the image for you and redeploy it. Well, it needs to have access to the Docker daemon itself, and it runs as a container, so you mount the socket in there. It's a bad idea. I stopped using that a long time ago because if that Watchdog container ever gets compromised, it now has full access to everything else that's running because it has access to the socket. So don't mount the socket unless you absolutely need to, and most of the time you don't. There are other ways to do what you're trying to do. Obviously, making sure we're not including vulnerable binaries, making sure that you have an accurate inventory system or a product. Sneak's a great example. There's a lot of them out there, but they're probably the most popular, where you're analyzing your repository, you're analyzing your Docker file. That thing that had all the layers, I forgot to mention that, by the way, it's called a Docker file. You need to be making sure you're scanning that and making sure, hey, there's no vulnerable binaries in there. Making sure I'm not installing a version that's old that has a new CVE with a high CVSS or something like that. So that's pretty basic. And build secrets. Sometimes whenever you're building an image and you're copying your company's code repository, you got to have maybe an access key, an API key, what have you, client secret ID, something like that. And a lot of people just hard code that right into the Docker file. And they think, oh, it's good because the repo is private, where the Docker file lives. Only people in our company have access to it, and we have good RBOC controls on the repo. I'm set. Well, you're not really. Because again, if you remember, that every line, every layer in that image that I built is cached and it's read-only. So theoretically, you can peel back the onion, not theoretically, practically, you can peel back the onion, and if someone gets a shell access to that container, they could find that build secret and then obviously use that for other things. So don't hard code build secrets. Have good secrets management using something like HashiCorp, other products like that where you can inject build secrets into your pipeline. Even Jenkins. Jenkins has their built-in user or credential store. That's even that's an easy alternative to injecting these build secrets directly into, or hard coding them instead of injecting them. So into the Docker file. Then in our registry, making sure we have good RBOC controls. Who has access to push and pull? And I'll explain why that's important. Obviously, who has access to delete? You don't want people just deleting your stuff. If they don't need that permission, don't give it to them. Principles of least privilege. But the reason why I say push and pull is specifically, we'll talk about this here in a second. Actually, I'll move on and then I'll come back to that. Encryption at rest and in transit, that's an obvious one. Don't send things over clear text. Don't store them in clear text. Encrypt everything at rest and in transit. But the push and pull, I think I'll go to the next slide. Here's why it's so important. Unit 42, this is back actually from 2020, this report, but there's an updated report, and Aqua Security, I don't know if y'all are familiar with Aqua, they actually just released earlier this week, I didn't even have time to put it in the slide, their findings on registry security, what they found out in the wild. And the reason why I mentioned your push and pull operation as being important for your registry, if you don't give proper permissions to push and pull, let's say you leave the pull operation. You think, oh, it's no big deal. It's a compiled image. No one can inject a secret or inject malware into my thing. They can just pull it. Well, the problem is you give them a chance to analyze your environment better. You've given them access to your system indirectly because they now can peel back the onion of the container and look where a vulnerability might be. Okay, so having correct RBOC controls on the pull, but especially the push. Now we're talking about supply chain attacks. Someone, if you have an unauthenticated push operation, like you just allow push operations, anybody could pull that image, or even, let's say they don't pull it, they just build their own malicious container that does, just nukes everything. Well, you've now allowed them to implement supply chain attacks, and obviously we've heard a lot about this in the last few weeks with 3CX supply chain hack, and there was another one they were a victim of another supply chain attack. It was like the first double supply chain attack in history. But with containers, it's really easy. People just miss this. And it's not getting any better. Again, this is from 2020. I hope maybe it would get better. It's not. Aqua Security proved that with their findings. Actually, it was just like Monday or something it came out. But here's the stats, but I'll read you a little excerpt from the article that they published. So our research identifies 941 registries exposed to the internet and 117 registries accessible without authentication. There are a total of 2,956 repositories and 15,887 tags. So whenever you build an image, it tags it. So a bunch of unique images or versions of images. Out of the 117 unsecured registries, 80 of them allowed the pull operation. 80 of them allowed you to just pull down their code without any authentication. The 92 registries allowed the push operation. 92 allowed people to inject their own containers into the supply chain with zero authentication. And 7 registries allowed the delete operation. I mean, denial of service. I mean, that's huge. Without looking into image content, so they didn't actually start looking at it, we could attribute about 25% of the unsecured registries by reverse DNS lookup or CNAMEs in TLS certificates, meaning they just found this with public data. That's it. The owners of these registries range from research institutes, retailers, news media organizations, technology companies. Some exposed registries have more than 50 repositories and 100 tags exposed. With all the source code and historical tags, malicious actors can design tailored exploits to compromise the systems. If the push operation is allowed, benign application images may be replaced with images with backdoors. These registries may also be used for hosting malware. If the delete operation is allowed, hackers could encrypt or delete images and ask for ransom, denial of service. As each registry is typically accessed by multiple clients, here's a big thing. All the clients who pull and run images from those compromised registries immediately become vulnerable. You can't trust that the hosts that are pulling and using those images are now secure because they've pulled unvetted, unauthorized code, potentially. It's a big deal. And how can we secure our container runtime? Again, this is Docker itself, the actual binary that's running the daemon and all the underlying API and all that stuff. Obviously, there's CVEs for the runtime. Make sure you're updating Docker itself. You can't just assume, well, I've updated everything in the image, I'm secure. No, you still got to make sure your underlying engine is updated because there could be an exploit for Docker itself. And then the configuration of the runtime, again, configuration is usually where you have the most mistakes and expose yourself to a lot of vulnerabilities. Running it as rootless, I remember I said Podman has a lot of rootless features that you can implement easier than Docker. Having a read-only file system. So the underlying host that's running your container, everything should be read-only except exactly what's necessary to run Docker. In fact, I'll take a quick pause on this. What's time? About 20 minutes, okay. I'm working on a project called PwnCube. It's a Kubernetes exploit path. And what I actually figured out was I was able to exploit an Azure Kubernetes service, so AKS cluster. I was able to get an exploit in there, and they don't have root-only file systems. I was able to get a shell on one of the hosts, the worker nodes of the Kubernetes deployment or the Kubernetes cluster, and install a cron job that pinged out to my C2 server. I just needed a proof of concept there, but it was not read-only. I could just access it. Okay, so even if you're like, oh, everything's locked down to root, not good enough. You need to make sure it's completely locked down and read-only. If you're running Docker itself, like you're running it individually, drop Linux capabilities that the actual engine shouldn't need. You usually want to give Docker certain Linux capabilities like netadmin, things like that, because it may need to give a container a certain privilege. Well, whatever you don't need to give your containers, make sure Docker doesn't have access to either, because if Docker ever becomes compromised, it now has more than it needs, more permissions than it needs. And then don't run containers as privileged. Make sure you're running them as unprivileged. Pretty simple there. And then in the orchestrators and hosts, again, kind of similar to the other one, this is really kind of hand-in-hand. Secure your host, root-only file systems, things like that. Follow basic host hardening. It's really simple. Protect yourself against container breakout. Making sure you do security scanning within an orchestrator. Again, now we're talking about Kubernetes, things like that, OpenShift. Make sure you're scanning that environment itself, the actual orchestrator, the API environment. Check how your networking is configured. How is your storage configured? These are all done via like drivers and plugins. How is your networking configured? Is it encrypted at rest? Is there something encrypting it in transit? Same thing with storage. Networking, making sure you're having good like firewall rules, things like that, they still apply. Even though it's a container environment or an API environment, basic rules still apply here. And then your API access, making sure you have good RBOC controls on the actual Kubernetes API, okay? And so now, having seen all of that, let's look at the entire container security lifecycle. Again, this is kind of my own, from building images, deploying images, and securing them. This is kind of my own idea of what a container lifecycle should look like. In our build stage, this is where we apply the concept of shift left, okay? You've all heard that term, buzz term, but it's important. Pushing security operations further left, or for you guys, left, in the development cycle. Are we scanning these things at build time, or are we waiting till they are at, hey, we're ready to run this, can we scan it and figure out if there's any vulnerabilities? No, 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 you should do that way further on in the process, earlier on in the process, excuse me. Establish your image chain of trust. Like I said before, what base images are you using? For an enterprise application, you may have heard of using like the Alpine base image. It's really small, really purpose-built, like 5 megabytes, but it's got a package manager, so it's really easy to use. If you're using that, great. But if you're not, and you're using somebody else's image, or even Alpine, actually, you shouldn't exclude Alpine just because they're really, known to be secure. You still got to establish that base image chain of trust. Know what you have in your environment and what you're introducing, because let's say they have a supply chain attack. Are you monitoring their stuff before you use it? You need to be doing that. And then using proper build secrets, mentioned that. Make sure you're injecting those, not hard coding those. And then shipping and storage, secure the registry. We talked about that. Palo Alto, Aqua, they've published some stuff on that. Please, please, please. It's just getting worse and worse. People spin up their own registries, or they use Docker and they just don't configure it properly. Have good RBOC controls. Secure your registry. Secure the image source. So wherever you're building it from, you can't assume that just because I scanned it and everything and I pushed it up to the cloud that it's secure. Maybe your actual host has some malware on it that's injecting something before you actually push. You don't know. Secure your host. Make sure you have good endpoint detection, things like that. That's a talk for another day. Secure the registry host. So if you're not using like a SaaS registry like Google or Azure Container Registry, GitHub Container Registry, things like that. If you're hosting it yourself, follow basic host hardening, things like that. Making sure you're encrypting your storage and all that. Most people don't do that anymore. They still use, like SaaS, the ones I mentioned before, but it's still very easy to misconfigure those. So just make sure you're checking everything out. And at your runtime, this is the real fun stuff. So at runtime, you can do a lot of image scanning and you can do a lot of security operations at runtime that you just wouldn't get in, like a static application scan, something like Sneak or other products that look at your source code or look at your registries. That's all static. It's not running anything unless they have a dynamic component where they're executing it in like a private environment. That's all static. And so in your actual runtime, you can do more. You can do more security and get more insights. I'll mention a few products. I've mentioned a couple so far. But for like runtime, you can use admission controllers, or you can use a service that does all this for you. One good one, or two good ones, Aqua and Sysdig, have a really awesome runtime security offering where they will monitor the actual system calls, the actual like kernel eBPF system calls, like as low as you can go to the kernel. They're going to monitor that and figure out what's happening in that container, what files are being touched, what permissions were used, what TCP calls did it make. Pretty much everything. You're watching the kernel, so you're seeing everything. Or you can use a little bit higher up in the stack, you can use what are called admission controllers, where you're monitoring the Kubernetes API. So theoretically, everything that's happening within Kubernetes is going through the API. And so if you're monitoring the API, you should be able to catch just about everything, again, specific to the orchestrator. So the admission controller says, hey, I'm going to evaluate every API call that comes through and evaluate it against a policy. If I have a policy disallowing maybe new files to be written or certain permissions to be used, I'm going to catch that and I'm going to stop it, I'm going to learn on it, I'm going to kill it, whatever. You can set that policy. So admission controllers, that's a great thing to use, or use a SaaS program or application that will help you automate all that and deploy it at scale, like in an enterprise. Image pinning. So again, if you remember, when you build an image or even a layer, it's all hashed. And then when you build the final image, it's also basically a cumulative hash. If anything changes in that image, there's a new hash. So when I'm building, typically you see like latest tag. That's a default tag that you use in Docker when you build an image. That is what's called a mutable tag. If you change something and you retag it as latest, it just overwrites the old one. An immutable tag is the hash. If anything changes in that image, there's a new hash. The old hash cannot exist, or it's not valid if something changes in there. It's immutable. And so by using the process of image pinning, it's a very hard, very complex process, and it's not easy. It's not for a lot of teams, to be honest, but this is like next level. You're saying, instead of saying, I want to pull, whatever app name latest, I'm going to say, I want app name, and then you give it the long, whatever bit hash that it's got. Now you're saying, it doesn't matter if someone has a supply chain attack on me, and they push something, or they pull it, and they figure out how to reverse engineer my application and inject malware. It doesn't matter, because I'm saying I've scanned that hash, and I know it cannot be changed. And before I run, I can use the admission controller to say, hey, is there a new hash out there? Then I'm going to try, I'm running. If there is there a scan? Is it in compliance? And if not, don't let it run. And so you can kind of combine a lot of these things within, like in this one in particular, it's Kubernetes using the admission controller. But with image pinning, you can use that with Docker or Podman or anything like that. Host security, obvious. Make sure you've secured the host. And then network security, again, basic rules still apply. Making sure you have good firewalls, good rules on that. So some tooling considerations. We're kind of nearing the end of the presentation. This is not an exhaustive list, but these are some really, really awesome ones. Sysdig, I mentioned them. They have an open source tool called Falco. Falco, again, is the tool that sits at the eBPF layer of the kernel and is watching everything that happens. And you set up your policies and your alerts, but you can just log everything, and then you can have some third-party tool like Splunk, Elastic, whatever, monitoring for particular events that Falco is catching. Sysdig also sponsors KubeShark. I think the founder of Sysdig is one of the co-founders of Wireshark, the original co-developers, and the person now in charge of KubeShark was the other developer of Wireshark when they first started. So they've kind of come back together. And so this is basically Wireshark for Kubernetes. It's a really awesome tool. You get super detailed information, and you can combine that with Falco alerts to get insights like, hey, an event fired off. What actually happened? Well, now I can go into KubeShark and look at the actual network calls, look at the file calls, the system calls, and things like that. Or you can just roll up and use Sysdig's SaaS offering, and they do all of that under the hood for you. Same thing with Aqua. They have an open source tool called Trivy. Both of these companies, by the way, have been avid supporters of open source, as well as Sneak, huge supporters of open source software and the community. So definitely check them out. But Trivy is kind of your static scanner that you can run in your build pipeline and say, hey, do I have any vulnerabilities in here? It looks at everything in the image, looks at all the versions, and checks that out. And they also have supply chain, much like Sysdig, they have supply chain runtime security in their SaaS offering. So if you're in an enterprise, definitely check out these top three. These are probably the biggest when you're considering security from a developer or DevSecOps point of view, not from like a cloud, I'm going to throw out another term, the CSPM perspective. That's from the angle. So you got your developers coming into the cloud this way, and then you got your cloud administrators or your cloud engineers. They're concerned about the actual cloud components. The actual setup of the Kubernetes cluster, the actual setup of your VMs and things like that. Prisma Cloud, they're pretty big in the CSPM as well, honestly, as well as the developer aspect. But if you're really coming from the DevSecOps perspective, these are probably your top three. And again, I mentioned they're huge in open source, sharing of knowledge. Sneak actually sponsors DevSecOps. They have a division of their company that all they do is they pay them to manage these communities. So they're really giving back and making sure that people are getting educated on these. Let's see, so this is one that you can just use, no tooling, very much like Trivy. This is open source. Claire will just look at your image and it'll spit out a bunch of CVEs. Hey, you got all this stuff. Here's the actual description, what's going on, what can people do. Really great for static application scanning. That's called Claire, and you can run that locally. Yeah? Yeah, this is, so here, Claire scanner, and then you are looking at the actual image tag. So I'm looking at PHP 7.2. So if I don't have it, Claire's gonna download it locally, just like Docker will, and it'll scan it. So that's scanning from a registry. You can scan your own Docker file, so it doesn't have to be in a registry, but this one in particular, I'm scanning something from Docker Hub. Great question. And if anybody has any questions, feel free to interrupt me, and we'll have time at the end too. Dockle, this one was probably one of the first tools that I started using, gosh, about 4 years ago. Dockle is what we can use to help look at best practices. It can look at the image and say, let's see if we can get through here. App credentials.json, yeah, that's probably not a good one. Let's see, remove the APT lists, kind of shrink your image size, making sure you don't leave things in your image. Or it may say, another thing I forgot to mention before about your caching is it's gonna scan each image, even though it's read-only. So let's say I include that credential file. And then in a subsequent layer, because I needed that credential file, in a subsequent layer, I delete it. I think no harm, no foul, it's gone by the time the image is built. Problem is it still exists in the previous layers. It was just masked over. So Dockle's gonna go, hey, I found that file in one of the layers, which if I can, anybody else can too. Let's see, what's another good one? Don't use no password. Confirm your permissions on these things. I found the MySQL password is hard-coded in an env environment variable. Things like that. Last user should not be root. You know, so best practice assessment, yeah. Say that one more time, I couldn't be ready. Yeah, so yeah, this will check, the image that I didn't scan didn't have anything running as sudo because I was running it as root. So this didn't exist. And this, again, is, let's see, this was a test image that that I pulled from a tutorial where they intentionally left in a bunch of this stuff. But yeah, if you're running a sudo, Docker will catch that, or other tools like it will catch your best practices. And it kind of help you do a health check on your image. Am I doing something that's against best practices? Again, a lot of your enterprise tools will have this baked into their products right out of the box. All of them I mentioned in the previous slide will do that. Docker Content Trust, this is another one saying, hey, you haven't enabled Content Trust, which is another layer of immutability. You're explicitly saying who I trust, things like that. Hey, you should do that. So that's Dockle. I have a few more tools I could talk through, but obviously I want to leave a few minutes for questions and all that. But hopefully this will help containers to you not be a black box. Because without using the right tools, without using and knowing the fundamentals of how containers are built, they're black boxes to traditional security professionals. So with some of these new tools and the idea of the container lifecycle, containers won't be a black box anymore. So I do have some time for questions if anybody would like to ask. Yes. Yeah, so the question was any particular opinion, or I guess opinion would be a good word, on the difference between like Azure Container Registries or security issues with Azure Container Registry, Docker, things like that. The answer is no. As long, again, we're assuming that they are patching their own systems. If we can assume that, obviously if they're not and something is disclosed, then yeah, that's a big deal. Yeah, okay, great question. So any security configurations that are common in like Azure, Google, Docker. The biggest one is RBOC controls. So if I'm using Azure DevOps for my code repositories, my build pipelines, and I'm using Azure Container Registry to store my actual images, am I giving the right people access to that repository? How am I auditing those users and groups is probably what you would use like Azure security groups and things like that. That's probably your biggest misconfiguration that you'll see is not limiting the permissions that they have to the Azure API or things like that to introduce a supply chain attack, for example. But the underlying SaaS application itself, no, I mean, they're all pretty much the same as long as, again, they're patching their systems. And obviously some will have issues more than others, but for the most part, they usually do a pretty good job of staying up to date because a lot of people rely on. Yeah. Yeah, so I would like to say, well, I have two answers. One, the host is probably easy to miss because that's not what your developers are like working out of. They're working out of, like, let's say they're using Kubernetes. They're more concerned about Kubernetes itself and making sure that it stays updated. But honestly, I would love to say that developers are being secure and constantly scanning their images and doing best practices here, everything that we've talked about, but they're not. So probably evenly split. But containers are a little bit more complex. They introduce a lot more potential issues, misconfigurations than a traditional host. Again, that's more traditional security, host security. And so I would say containers is probably the bigger threat because of the amount of complexity. However, that doesn't mean the host is any less important. It's super important. Yeah. Yeah, so most of the time the question was the different types of like socket or the communication to the Docker engine. The socket is just one type. That's usually the most popular. Since it is a file socket, like a Unix socket, for example, it is by far the fastest. Your latency is going to be almost none versus you can run Docker, for example, with a TCP daemon socket. You can access it over a network, which is highly, highly, highly unrecommended. Docker does provide best practices for that, RBAC controls, network security controls, things like that, but that's not recommended. So the Unix socket is the most popular. You can do TCP socket as well. Yes, are you? Can you say that one more time? An immutable runtime? Yeah. Right, right, right. Yeah. Yeah, so the question was about like an immutable, I would say like the underlying host or the runtime, what does it have access to? Like, so So maybe I could talk to you after, just better understand your question, but having root-only file systems, running your daemon, or your engine, I should say, dropping Linux capabilities, making sure you're running it as rootless, or without roots, without elevated permissions. But maybe I could talk to you after, get a little bit better understanding of what you're talking about. Yeah. Yeah. I'm sorry, say that one time? I can make them available. If you want to come up to me afterwards, I'll get them available. And then, sorry, I can make them available. And then if you want to come up after, I can talk to you, but they'll also be on the YouTube recording, I believe. Everything's being recorded, so you can find it there too. I can't see anybody else. Yeah.
Curious why you prefer
LXC just for where I'm trying to get as close as I can to a virtual machine. I don't prefer it for all workloads, but like at home, for example, because I have cheap hardware and I don't want to virtualize everything in a VM, I use LXC because it's lightweight enough, but it still is most like a VM in that I don't have to have constantly running processes. Like with Docker, when the process quits, the container quits, unless you automatically restart that. And for a lot of the stuff that I'm running, I don't want that. And so that's why I prefer LXC for when I want to get as close as I can to a VM without actually having all that overhead. Yeah. Say that last part one more time. Yeah, I may need to talk to you after. That might be a little bit longer of an answer. And also, we are out of time. But yes, I want to talk to you about that. Any other quick questions? No? All right, well, I'll be up here if you have any questions. I appreciate it, guys. Thank you.